All right, good afternoon, everybody, and welcome to part 3 of the NEWCOM and Neverfail webinar series. Today, we're going to focus on avoiding catastrophic disruption, protecting critical public safety systems from cyber attacks and system failures. I want to let you guys know that this session is being recorded, and we also recorded part 1 and part 2. So if for any reason you missed those or you just want a refresher, go over to our website, newcomglobal.com, click on the resources tab and webinars, and from there you can download session 1 and session 2, which were all delivered by the exceptional Michael Wrightson. Friends call him Mike, of course. He is the GM for Neverfail and is a true veteran of the of the industry, and he's here today to deliver part 3 of our series and finalize it out. So without further ado, I'm going to turn it over to you, Mike.
Well, good afternoon, everyone, and thank you, Jim, for the kind words. We are on the third and last webinar in this series, so we have a lot of cool things that we're going to show you in just a couple minutes here. By way of review, though, if you've actually been following this webinar series, I just wanted to quickly review what we've covered so far and how this is going to link in this third and concluding presentation. So when we first started the series in webinar 1, we covered how important it was for disaster recovery to ensure that you have really quick recovery in the event of a natural disaster or man-made disaster. So being able to do disaster recovery to a different geographical location in a different data center. And then as we concluded that full presentation and we went through the whole aspects of why you need DR and how it could be designed, things like that. We followed up with a demonstration of how quickly we could literally move workloads between different data centers, and I believe we were able to demonstrate this in about 90 seconds or less. So that's really when you're talking about orchestration of a disaster recovery capability, that is really what you want to achieve, is the ability to restore critical applications such as CAD systems and very critical applications in very, very short periods of time. So then as we moved into the second webinar, we kind of covered a different type of use case. And so we started talking a little bit about how high availability plays into a BCDR strategy and how to build a continuity plan based on this. And when you do this, you have to take into consideration things like hardware, software, networking failures, and plan for a wide ranging outage within your data center. So, and we also talked a little bit about how full automation can help with when your organization has incapacitated IT staff due to a pandemic, or there's just nobody there to push the button. So orchestration and automatic rules for failover become paramount when you're trying to restore business services locally. So today, what we're going to do is we're going to finish up this series of presentations with a discussion around cybersecurity. So in the last few years, this has become especially of concern to a lot of organizations. And so today we're going to show you how quickly you can recover, plan for, and recover systems taken down by things like ransomware or even data corruption of some type. So with that in mind, let's go to our agenda for today. So we're going to talk about is why cybersecurity and continuity are so important. Right. So we've talked a little bit about this, and each presentation kind of built up on the same concept. So now we're going to add cybersecurity to the framework here. We're also going to talk about what the causes of downtime are. This is kind of a reminder. If you saw some of the other presentations, we went through some of the stuff, but we'll give you a different angle on it this time. And for those who are just joining us on this, this should be very informative. We're also going to talk about what the real cost of ransomware is, right? So if you get hit by this and your critical systems are taken down, what is it going to mean to you from a financial perspective? Then what we're going to do is talk a little bit about the, what DR and business continuity are and what the differences are. So again, the last one that we had went into a lot of differences. So we're not going to go into a lot of detail here, but it sets the stage for what we're going to do. It's how to prepare for this disaster, right? So we will take you through a product demonstration of Continuity Engine and how Neverfail, the approach to this, is unique in the industry. Okay. So with that in mind, let's talk a little bit about how do we begin this process, right? So from a planning perspective, there are multiple different things that you need to consider. And throughout the presentations, as we said before, we talked about everything that is not highlighted, right? So today, so we talked about building tiering for your RPO and RTO strategy, determining technologies that you need to meet these SLAs. We need to determine, the interdependencies of these applications. We need to, also understand the critical nature of the applications that you're supporting. You need to determine also, the number of times you need to test per year, right, to make sure that your disaster recovery plans works. And then finally, analyze the cost of implementation versus, on-premise versus even doing things like in the cloud, right? But what we haven't talked about yet is, and we've kind of touched on this a little bit in, I think maybe presentation 1, is what it takes to build a continuity plan that is, that is integrated into some type of cybersecurity framework, right? So that's what we're going to do for the next 45 minutes to an hour. So why is it so important to integrate a BCDR strategy into cybersecurity? Well, a lot of the industry is now just awakened to this new normal, if you will, in the last 2 to 3 years, where we've seen ransomware attacks just popping up everywhere, and nobody's immune to this. Every vertical, every type of organization has been affected by this, whether it's state and local government, it's banking industries, tech companies, a lot of technology that goes into this. And these guys are smart. These people are geniuses when it comes to creating these different technologies around ransomware. So it'd be no surprise that they would figure out ways to infiltrate different types of organizations. So this is what we're kind of seeing from the industry coming out, that ransomware attacks are increasing almost exponentially, and this is since 2017. 35% of those affected took a week, if not more, to restore from full backups. This is, we saw that. I live in the Atlanta area, and we saw a lot of these things happening in some of the state and local governments in Georgia. Ransomware generates over 25 million in revenue for hackers each year. That is surprising. Some people are just like, you know what? We ain't got time to do the restore. These are too critical of a system. Just pay the guys and let's get out of this. And so, so these are statistics that we're seeing today that are actually pretty scary. That, one, it's costing millions of dollars to recover. And you have a choice whether you want to actually take the burden of the additional cost of just wiping your systems and starting from scratch and just restoring from backups, or you take your chances of whether these criminals, if you will, are going to give you, once you pay them, they're going to give you the keys to unencrypt your systems so you can continue on. But either way, this is a new era that we've entered into. And there isn't a lot that we can do once it's underway to stop it. But what we can do is figure out ways to easily recover from them. So that's really the purpose of what we're going to be talking about today. So from a cybersecurity perspective, what's driving BCDR? So as we continue to, over the last 5 to 10 years, we've seen different cybersecurity frameworks emerge that all say that backup, or I should say a business continuity and disaster recovery plan must be an essential piece of your cybersecurity policies. Why is that? Well, you know, if hackers get a hold of this data, or they impair the ability for you to access these systems, this is a cybersecurity threat. First of all, how did they get access to these systems, right? So you need to figure out why that happened. But more importantly, is if they do get access to them, how do you quickly recover and get back up and running? So a lot of the new standards, such as the NIST 834 Rev 1 and 171 Rev 1, which is for the federal government and also for the Department of Defense, these are really good standards to kind of build your continuity plans under. There are also others that have these types of frameworks. So the ISO 22301 2019, that actually has requirements under it for cybersecurity framework, if you will, for business continuity and disaster recovery. If you're going with a SOC 2 audit, that also has requirements for business continuity. So it's starting to spread now into all the major frameworks, including the Department of Defense. We have the new CMMC and DFARS, which was kind of the old version of this. But the standards for CMMC have really stepped up to the plate. They've expanded some of the capabilities within that cybersecurity framework and added more requirements around this. So, and it doesn't stop there. Also, from a regulatory compliance perspective, you have all kinds of federal regulations that support these. So the idea here, the takeaway is that you can use a cybersecurity framework to build a very robust disaster recovery strategy. Now, in the previous presentations, we said, hey, look, there are different plans that you can get for free. There are things that, like ready.gov has a disaster recovery plan. They are good. They will get you back in operations. But building that disaster recovery plan around a cybersecurity framework tightens the rope, if you will, so that you can ensure that you've done all that you can do in order to sustain your infrastructure in the case of a cybersecurity attack. So we've talked about this a little bit in the previous presentations, but just kind of understand that there are many different things that could affect the operation of your critical application. So the network, we talked about networking and hardware and operating system failures and application performance and accessibility issues. People are imperfect; they make mistakes. So even user-related failures come into play. All of these kind of center around the data itself, right, and protecting the data. But now what we've added in the last few years is a new area of risk, which is ransomware and malware, cybersecurity related requirements. So since probably, this really started breaking out in, maybe 2014 and 15, we started seeing the first ransomware attacks. But, in earnest, it actually made the papers. It might have came before that, but right now it's never been. In fact, actually, I've been reading articles that says it's actually grown in significance in the last 3 or 4 months, just because we're in the middle of this pandemic. So the attacks have gone up, exponentially because they know that a lot of companies' IT staffs are, kind of in lockdown right now. So this is a big area for us to address. So now let's talk a little about the cost of a ransomware attack. So back in 2016, you think about $1 billion, you're like, God, that's so much, that's crazy amount of money that can, that costs, our businesses, our organizations here in the United States, and these are just U.S. numbers, right? $1 billion in the United States alone. Then as this problem continued to grow worldwide, now you start to see this real cost of this across the globe, where you're starting to see, organizations like the United Kingdom Health, National Health Services and Merck Pharma in the Ukraine, they had big breaches with with ransomware. This year, it's driving more towards, or I should say, in 2018, we started seeing municipalities taking a hit on this, and now it's pretty much a lot of this is going towards municipalities, school districts, MSPs, even, believe it or not, radio stations are being targeted for this. So what we're seeing here is a pattern from 2016, 15, somewhere in there to now, where they progressively started targeting different types of verticals, right? So different types of industries. So in order to not only steal information, private information, but also make money from these hard lockups and encrypting very critical systems. So this is kind of where we're at, and it's only growing. So so we saw in 2018, 2019 kind of a leveling off of this, but once we started 2020, there's been multiple articles that said that it just exploded because of the pandemic, and they knew that a lot of IT organizations were kind of in disarray right now because they're trying to enable the mobile workforce, if you will. So the attacks went up substantially in the last 4 or 5 months. So this is why you need a comprehensive BCDR strategy, right? So we've shown some of these statistics before, but just as a reminder, 80% of small businesses are prone to ignore or delay investments of business continuity and disaster recovery, just because it's really about cost versus risk, right? But when it does happen, it's usually catastrophic because they haven't made these investments. And even small municipalities that are and now it's even worse because of the pandemic. There's budget shortfalls, and a lot of these organizations are now trying to figure out. These municipalities are trying to figure out exactly where they're going to spend the money, right? Because quite frankly, the tax money is not there, right? But we know that if we don't do this, that your chances of survival if you have a major disaster are going to be very small. So it says only 22% of organizations with a business continuity strategy, or that are without them testing this, will actually survive the disaster. So you can put a disaster recovery plan in place, but unless you test it, and I've kind of used the term test in the previous presentations. If you don't test this, then you have absolutely no idea if this is going to work or not. And if it does work, it'll be complete disarray as you try to recover these systems. So that testing piece is going to increase, or I should say, decrease your risks when you're going across the board. The annual, losses are staggering for this, right? So statistics shows that climate change related disasters are increasing and affecting millions and millions of people. So you think about the displacement of businesses and different types of jobs. People, this is ruining people's lives as we continue down this, the related, unfortunate related incidents based on climate change. So these are 2015 numbers. But I've seen new numbers in the last month or so that kind of are into almost 500 million now. So this is serious stuff, and we have to plan for these things. And finally is ransomware, right? So this is our new normal, if you will, the cybersecurity risk. So they started taking statistics around 2016, 2017 when they felt that this was going to be our new normal. But when you look at the numbers in 17 and 18, it just went up almost exponentially, right? So it went from 184 million to 204. I think it's going to be, they're thinking somewhere in 2020, it's going to be around 240, 250, but it's beginning to level out. But they didn't plan, when they put those statistics out, they didn't plan for the pandemic, right? And everybody has seen that there has been an increasing cybersecurity attacks based on us having being under lockdown. So when it comes to business continuity and disaster recovery, they're not the same. One is a business continuity plan is more proactive. It's really just planning what could possibly happen, and then get the mechanisms in place to ensure survival, right? Where a disaster recovery plan is reactive. This is what happens when a disaster happens and how we will recover these systems, right? And it's more of a from a technical perspective. So, but the DR disaster recovery plan is part of an overall business continuity architecture and framework. All right, so now let's talk a little bit about technology, right? So, you know, we've been in business for and doing this continuity practice for a little over 20 years now. We actually started as from a Neverfail perspective, if you will. We started as a consulting firm back in the late 90s, and we were kind of doing a lot of work around, you know, Microsoft Failover cluster and fault tolerance and things of the technologies that were available back before the turn of the century. So, but what we did was we found that there are different things that just weren't covered by traditional hardware-driven application protection. So when you look at this holistically and you look at all the technologies that are out there, they really kind of fall into three categories. There is data-driven protection models that are recovery-centric, right? So you back up your data, you recover it, right? And whether it's on the same server or on a different server. That takes time. It has high RPOs and high RTOs, but it works. It's proven technology. You still have to do your backups no matter what type of high availability solutions you have today. It is a proven technology, but it doesn't cover all use cases. It doesn't ensure that your application will be back online within a very, very short period of time. So that's where hardware-driven technologies come in. They kind of augmented this and said, okay, now what we're going to do is we're going to try to protect the physical hardware to ensure that the application server in of itself can be recovered quickly in the event of a hardware failure. Well, again, this doesn't cover all of the bases, right? So essentially, virtual availability, like a vMotion, if you will, for in a virtual environment, some type of fault tolerance, or even, you know, the Microsoft Failover cluster still is a major seller today, but all of it is designed to provide you hardware redundancy. Where we saw the need 20 years ago is, you know, we knew these types of technologies already exist, but we saw that there are problems that happen inside the application server itself. And this is really, we've talked a little bit about this in the previous presentations, but, you know, just to give you a common statistic, Gartner Group said that has published many times that 80% of all application outages are because of an application failure itself, not because of hardware. Actually, it's only like 20% of all failures are hardware related. Well, hardware has actually gotten very, very good in the last 20 years, and it's you know, it's designed to last 5, 6, 7, sometimes even 10 years without any types of failures. And everything's redundant now. So even if you did have a CPU failure or a memory module failure, or you know the power supply went, you can just plug and play these things. Just pop one in, pop one out. But it doesn't take down the business service. You just get an alert that things happen, right? Well, why can't we just do this plug and play operation at the application layer, right? Why can't we just see when these events happen and be able to proactively address these? That's where continuous availability comes in. So continuous availability is typically driven by application awareness and being able to see what's happening inside that application server at multiple different layers. So we're talking about at the hardware layer, I should say at the network layer, at the hardware, the physical hardware or the virtual hardware layer, the operating system, looking inside the application itself and see its performance and whether its services are available, or even if the application from a user perspective is actually accessible. All of these kind of play in and provide you with an automated, fully orchestrated process for recovery based on monitoring of those different things. So this covers the gambit of all of the things that could potentially happen, including, by the way, the outages that are due to failures based on ransomware, right? So the idea is to get you as close to zero RTO, recovery time objective, and RPO is possible. So you go from a recovery-centric strategy over to an availability strategy. So why is Continuity Engine such a different type of technology? Well, really because it's our approach to continuous availability. So a lot of organizations will try to build up a server and try to replicate the data over, and at the time of failure, try to make it look like the old server. Continuity Engine has a completely different strategy, and the idea here is continuous availability. So we want to take as many obstacles out of the way that could potentially make your failover process less complex and more problematic. So the idea here is we start with a true clone-based architecture, right? And what do we mean by true clone-based? We basically just do a snapshot copy of your production server and set it aside. That's what we do. So Continuity Engine then replicates the minute changes of the application and data sets over to that snapshot copy real time. And so if something happens to the server that is caught with our continuous monitoring capability that is application aware, we could trigger recovery actions to restore that business service onto that same server, but in within literally just seconds to a minute or two. It's very fast, very effective, and it reduces the complexity of using a clone-based architecture. Reduces the complexity of the failover process. So you don't have to worry about rebooting servers and having to make registry key changes that are incompatible or not enough there to properly restart and connect to other applications. All of those go away, and also the security context, right? So you got to make sure that the application and also the different aspects of it being able to talk and allow users in and be able to talk to other dependent applications. So clone-based architecture, real-time replication, provide the low RPO and RTO, and then the application or the continuous monitoring is your application awareness layer that allows you to detect these anomalies happening and then trigger the orchestration process for recovery. All of this kind of is surrounded by a data protection layer that sits on top of the replication system that will allow you to take periodic snapshots of the data sets that we're protecting in order for you to be able to roll back in the case of some type of major corruption to the data sets. This is where cybersecurity protection comes in. So as we're replicating this data real time, if some type of ransomware attack happens, some of that data is going to come over before the server fails, and it will be reflected in your local data sets. So our data protection model provides you with that additional layer of protection. We'll talk about that in just a couple minutes. So all of this kind of comes together to give you zero distance limitations. It gives you flexible deployment options. You have low RPOs and RTOs, seconds to just a minute or two, very fast. The idea here, guys, is to keep everyone connected all the time. That is really what we're in business for. And we have not only customers that we're supporting on CAD systems, which are, I would say, probably one of the most critical systems in our country. But we have other customers that are doing other things. So, we have building management systems. We are protecting medical systems. Airlines are using this to protect their flight control systems. So there's a lot of different technologies out there that are very critical, and they trust Continuity Engine to do this. All right. So now let's talk a little bit about data protection. So now, since we're talking about this ransomware thing, how do we protect and recover from this? Well, Continuity Engine provides multiple tiers of data protection, and we start with the real-time replication system. So that is essentially get you as close to the failure event as possible. But because it's so fast, we could inadvertently replicate some of that corruption over real time. But the idea here is if you didn't have a ransomware attack and you just had a system failure for some reason, then we could get you as close to that recovery from a data perspective with the least amount of data loss. But then there are other times where you need to roll back, if you will, because of data corruption due to maybe a corrupted database or even ransomware. So we have what we call a data rollback module that allows you to quickly recover from malware and ransomware. It gives you rollback capability in case of the corruption of data. It also enables you to offload your backups. So a lot of CPU and horsepower goes into running backups on your production servers. You end up usually having to do them in the middle of the night because you don't want them to impact user performance, things like that. But wonder if you could actually use your passive nodes to be able to do that. So you can actually use this to decrease the overhead of your backups. It also allows you to use third-party backup tools to back up these passive nodes and offload that data quickly and easy, and even during production hours without affecting the end users. And then, of course, we want to make this as low impact to the users as possible. So one of the big problems that we see out there is that, when you do a major Microsoft patching event, an update, we've seen this go for some of our customers 3, 4, and 5 hours. Just this thing just cranking away, just doing the updates. Just depends on how powerful the machines are and how many updates that need to be done. But this could be a really big, especially for critical applications. Those are huge outage windows, and it decreases your uptime numbers. It literally could take you from 4 or 5 nines down to 3 nines, which is hours and hours of downtime per year. So what we want to do is reduce the maintenance window due to these patching to near zero. And we can do that by allowing you to patch the passive nodes first, do that reboot process, then you switch over your users to one of your passive nodes and let them continue to operate on that. That only takes 30 to 90 seconds to do that, and then it allows you to patch your primary your primary server, which was the old active server. So you can go through that process, that 5-hour process, if you will. You can do it during the day because there's no users on it. Reboot it, everything comes back up, and then you can switch everybody back if you wanted to. So this reduces the amount of impact to your users substantially. And it also lowers the risk that would have if you had a bad patch that could have corrupted the server. Well, it's okay if you corrupted a passive node. You don't want to do that on your production server, especially if it's a critical application like that. Okay, so from a topology perspective, Continuity Engine gives you 3 approaches to this. So you have what we call local HA, DR, and then tertiary. Local HA is that clone copy, if you will, that snapshot offline copy that is sitting there on your local area network. And essentially, it is fully application-aware failover. So if something is detected, and within the application stack itself on the production server, there is a channel that kind of bridges the primary and secondary together. Secondary being offline, it can't be accessed by the users. It would just fail you over to the secondary, promote it to active status, and automatically bring it up, and literally 90 seconds later, you're back in business, right? And it also carries the same IP address. In a disaster recovery situation, you're in a different geographical location, but you still have this clone over at the other data center. So instead of it being automatic, which you can do with DR, it is possible, but typically our customers want to push button initiation of a failover process to a different geographical location. So you push a button, or you can configure it for automatic if you need to, but either way, that process is exactly the same. The only difference is that we assign a new IP address and update DNS so that it's viewable and accessible to other applications and users. The alternative to that is what we call tertiary, and this is a very popular offering that we have for Continuity Engine. And so it provides you both with local HA, that application-aware failover process that's automatic. You don't have to touch it. It just detects these problems and fails over. And you have a third resource over at a remote data center, and it's there in case you lose the server. They'll lose the entire data center. So these are the three options that you have. And again, these are proven technologies. I will say, if you're familiar with vSphere version 5, there was a product that you could buy from them, from VMware, called the vCenter Server Heartbeat. That was actually an OEM version of Continuity Engine. So we have thousands of deployments of version 5 of vCenter Server, and actually version 6 too, of vCenter Server Heartbeat out there. And it continues to run and protect it. So, and we were the only OEM partner that they had on their core stack. So it was really a privilege to work with these guys. Okay, so now let's talk a little bit about the data rollback module. So this is kind of where we're going to kind of set up our demo in a couple minutes. So when you're talking about ransomware, there's a couple things you need to understand. So you have a primary and a secondary server. You could have a third tertiary server if you're going to go for tertiary, but for the reasons of this demo, we're going to talk about a primary and secondary. Now, your database can be sitting on a volume there. We're replicating that real time over to its passive node, right? And then what we're going to do is we're going to enable the data rollback module that allows you to literally roll back from a recovery point. Those recovery points can be done either manually, or you can set up an automated process to do that. What's nice about this is that it really sets the stage to protect you from ransomware. So in a Continuity Engine deployment, the actual servers themselves are fully protected. So from an operating system perspective, they are absolutely isolated. So if the primary is the only one that is actually attached to the network and users and other things can find it, it could become infected if the defenses are not there. What's nice about Continuity Engine is that its channel, this guy right here in the middle, that bridges these two together, is fully isolated, right? So it only will accept replication traffic from the primary server itself, and it's only for its own services, right? So it only sees the data that our services is replicating. What's nice about it is that channel is hardened, so you cannot get ransomware coming in through the channel to the secondary. So from an operating system perspective, they're fully isolated. So, but the data is being replicated real time from the database. In this case, from the C database directory over to the same directory on your secondary. So there is an area in which you would have to recover from if that happens. That's where the data rollback module comes in. So you can set these recovery points either at a time delay, every day, or maybe every 15 minutes, every hour, on your passive nodes to reduce the amount of overhead on your production server. And then if something happens and we get this ransomware attack and it infects and encrypts the entire production server and it goes down, all we have to do is just roll back to the recovery point just before this incident happened, and boom, we're back in business again. So from that perspective, let's open this up for our demo. Okay, so what you're seeing here now is a live deployment of Continuity Engine. And by the way, Jim, can you see this? Can you see my lab here?
Yes, sir. You're live. We can see it.
Okay, great. So So let's talk a little bit about this. So what we're going to do is we're going to simulate, the best of our ability. We don't have ransomware here active yet, but God forbid that we do. But what we want to do is we want to kind of show you the workflow, if you will, of how you would recover in the event of some type of database corruption, right? So we have an HA pair here. This is actually the DR copy. This is a tertiary deployment. These guys are in my Austin data center. Notice that they have 0.27 as their public IP address. This guy is kind of grayed out. That's because he's offline. He's not viewable to the end users. But we do have a channel between them. So there's 2 IP addresses that allow them to replicate data real time, right? So let's take a look at what we got here. So this is my SQL Management Studio. And I have a bunch of databases here. So I got one for Stephen, Jared, Williams, and so on. What I'm going to do is I'm just going to kind of simulate a corruption event where maybe there was a malware or some type of virus that got in, even ransomware, but a virus that got in and just deleted all of the databases. So I'm just going to go delete this guy, delete this guy, delete this guy. We'll come back in a second here. So we're going to go ahead and delete this guy, and then there we go. And then we're going to delete Susan, Lou, and then more. All right, so technically we just got wiped out from a SQL server, virus that just deleted all of our production databases. Okay. So now what I'm going to do is I'm going to say, oh, wait a minute, it just disappeared. I need to fail over. We might have a ransomware attack or something. So I'm just going to fail over to my secondary server. So when we do this failover, there's a couple things that happen. So if the primary server is still available, and it could be yes or no, depending on the type of cybersecurity attack it is, 2 things are going to happen. One is if this primary server is still active, it's going to try to shut down the services that are there. If it is, if the services, and then does a clean shutdown of those services, and then kind of rolls over to the secondary, and then spins up the services and brings it to active status. But what's going to happen is if the production server is completely offline, the secondary will just seize the role of active, and then it will go through this transitional process and become the active node on the network. So once it goes through that, remember that in a local HA, it doesn't need to do a DNS change or anything like that. So you'll notice in just a moment when it finishes its transition, it will be highlighted and you'll see that it'll have the same IP address. So the idea here is that once this transition takes place, we have an active secondary server, but guess what? We're going to still have maybe some of the data will be corrupted because of this, and that's where our data rollback module comes in. And what we're going to do is once this failover is complete, we will, which it is now you can see the secondary server is up and running. So how fast was that? It was like maybe a minute, 90 seconds to get it up and running. But no, now we have databases that are missing, right? So if I go here, notice that they're gone. I'm just going to refresh this. They are totally gone. They are replicated over to the secondary. But now I'm going to go to our data rollback module. And I took the snapshot just before our demo here. So what I'm going to do is I'm just going, and this was done on the secondary. And what I'm going to do is go to rollback. And I'm going to have it restart the application and replication after the rollback rollback is completed. And so it begins this process of stopping the services on this corrupted SQL server. It'll take down the services. It then runs the VSS recovery module to actually restore the data from the last snapshot. And this usually takes about a minute or so. Well, it just depends on how much data there is, but it could take a few minutes, several minutes, depending on how much data change there is. But the idea here is that we're rolling back to the moments before this incident happened, right? So we know we have a server that is good, but the data sets that we're protecting are not so good, right? So as you can see here, it's going through a transitioning process. So it shut down the services, it's restoring the data, and then it restarts continuity engine and restarts the application, and everything comes back online again. So this transition will take probably another 15, 20 seconds. Once it's done, then you'll start seeing the recovered data that's been brought back to life here. Now, what you're going to do, what's happening in the background too, is that remember that the servers also have the same IP address, so we don't have to go through the process of doing a DNS change, if you will, or having to reconfigure this to be a different server. All this is done. So now we've just recovered our system. The restore, the rollback is done. If I go over here now to SQL Management Studio and then do a refresh, notice that all of our databases are back. So this is an amazing technology for protecting your applications in the event of a complete disaster. And what's nice about this is that one of those little checkboxes that I had when I initiated the rollback, one of them was to restart replication. So once we've restarted once we've got the data back on the production system, it automatically starts resynchronizing this data back over. So now, if I will go back to our primary server, it just completely reverses the entire process, right? So we're going to do a switch back now to the primary server. You'll see it in a second, go through this transitioning process, which you just did, just started. And it's going to shut down the services on the prime or secondary server, which are active with the new restored database. It will then hide itself from the network. It will then roll over to the primary server. It will unhide itself from the network. It will spin up the SQL services, and the data is already there, fully replicated, so everything just comes back online again. So this is the process that we use to fully recover, and as you can see now, it's going through the recovery steps. It's starting replicating from the secondary to tertiary. It's starting from primary to secondary, and now it's starting up SQL Server. And in a moment, we will finish the transition, and we'll get the green arrows going from primary, secondary to tertiary. All right, so now we have an active server. Notice that the primary is now active. Everything's replicating, and if I go to here, this is our server here, and I refresh, notice that all my databases are there. So now the primary is the active server, and it's replicating over to the secondary, which is the data, the new databases that we just restored from that cybersecurity attack. All right. So this is continuity engine. Now, a couple of things that we need to just as a reminder here. Let's see. There we go. So a couple things to keep in mind is that with continuity engine, there are different types of protection scenarios. We have, of course, a single server protection. We have application farm protection, which means we have multiple servers. We talked about the interdependencies of these application servers in our last presentation. and how that affects the delivery of, from a HA or DR perspective. So we do application farm protection, which is all the interdependent application servers. We can protect all applications that run on Windows for a full site recovery that could be literally measured in just a couple minutes in the middle of a disaster. So we liberate you from the, from the fear of having to restore some backups. What happens if you have to do 20, 40, 60, 100 Windows servers, you had to bring them all up. All those problems go away. You push a button and everything becomes active at your DR site. So a couple key takeaways from this. Disasters of all types are not an if, it's a when. It will happen. Nobody even suspected a few months ago that we would even be in a pandemic right now, right? So we know that these things are going to happen. And so it's not an if, it's a when. Ransomware attacks will continue, and they're going to continue to target different types of sectors, including state and local governments, and they're getting more insidious in different variants, right? So the hackers are not getting stupider, they're getting smarter, right? And so we have to provide a layer of protection to ensure that that we can recover in the event of a disaster. Most cybersecurity policies include a virtual BCDR strategy. So when you're looking at, NIST, the NIST 834 and 171, and some of the others that are out there, it's important to not only have a disaster recovery plan, but make sure that you are doing in accordance with cybersecurity policies. And Continuity Engine, as you just saw in this presentation, covers, is really designed uniquely to cover all the major causes of downtime. So we are in a very unique position. That's why we call it continuous availability. And speaking of that, this model is specifically designed for mission critical applications like Central Square, right? Central Square, and we've talked about all the other different types of critical applications that are available on the market. So when you look at this, it's a really, there's a lot of benefits to using Continuity Engine. You have, again, the security aspects of this, cybersecurity protection, application awareness, real-time replication and data protection. We monitor the networks so we can ensure that we can see those different anomalies happening even at the network layer. We give you full site level recovery, and we package this up into a very easy to understand and deploy model using Continuity Engine. And with that, we'll take some questions.
Awesome. Well, if anybody has any questions, feel free to submit those now. Raise your hand. We can take you off mute and answer those questions. I will tell you, Michael, right now we have no questions in the queue. Exceptional delivery of the content. We greatly appreciate it. I want to remind everybody that part 1 and part 2 are available for download. Just go to newcomglobal.com. You can reach our sales team at any point in time. Sales@newcomglobal.com. One of our engineers would be glad to answer your questions, walk you through, a disaster recovery plan for your organization, and we can bring in the Neverfail experts as well to have a very deep conversation around how to secure your mission critical applications. I want to thank everybody for their time. No questions, so I say let's wrap there, Mike.
Okay, thank you very much for everyone, Jim, and everyone who attended today. Thank you so much.
All right, thank you guys, and we'll send a recording out, and look forward to talking with you all soon. Thank you.